1.4, I'm going to refer back to my flow chart at the beginning of my notes, so we have an idea of where we are right now. We are all talking about quadrilaterals. We did the parallelograms. Then we did our fancy parallelograms. That's our rectangle, rhombi, and squares. Today we're going to talk about the non-parallelograms. Yes? That's why there's a partner quiz, because there's no review. I know. Okay, so non-parallelograms today. Trapezoids and kites are our focus. This means that we do not get any of our parallelogram properties. We had 6 parallelogram properties that we've been talking about for the last 2 days. We do not have those here. These are non-parallelograms. Starting with trapezoids. There's only one property of a trapezoid. It is its definition. The definition of a trapezoid is a shape that has one pair of opposite sides parallel. Parallelograms have 2 pairs of opposite sides parallel. Trapezoids have just one. We call the 2 sides that are parallel the bases. The bases do not necessarily have to be one on the top, one on the bottom. It depends on the rotation of the way your shape is drawn. They could be on the sides. The only thing that we know is that the bases are the 2 that are parallel to each other. The other 2 sides, the non-parallel sides, are called the legs. That's all we know about the legs, is that they're not parallel to each other. And that is our only property for trapezoids. However, when the 2 legs are congruent, we get a special shape called the isosceles trapezoid. The isosceles trapezoid is still a trapezoid. So it still has that trapezoid property of having one pair of sides parallel. So here and here. Still a trapezoid. But by definition of an isosceles trapezoid, we know that the non-parallel sides, aka the legs, are congruent. That is what makes a trapezoid isosceles. Questions on that? From there, we get a couple extra properties that come with it. Number 1 is that there are 2 congruent pairs of base angles. Base angles are the ones that touch the same base. So remember, base means the sides that are parallel. If I talk about this base that's on the top in this picture, its 2 congruent base angles are the ones that touch that base. If I'm talking about this base on the bottom, its base angles are the 2 angles that touch that base. They are not necessarily congruent to one another. In fact, I don't think they are, otherwise we would have a rectangle. But they are congruent to their own base angle. From this property, we are also going to get kind of a sub-property that's not listed here. But if those angles are congruent, then that means that one side must add up to what, do you think? 180. So those consecutive angles are supplementary. Let's say supplementary. Okay, good. The last property, we have seen this property before. Diagonals are congruent. Where have we seen this property? What other shape has this? Anybody remember? This is Caitlin? Yeah, it's a rectangle. Diagonals are congruent is a property we also see with rectangles. This says that AC is congruent to BD. That's all this says. When we were talking about this same property with rectangles, we were able to say, oh, this side, all these pieces must be congruent. We do not have that with trapezoids because we are missing that parallelogram property that allows me to do that. All I know with the trapezoids is that the diagonals themselves, the entire things, are congruent. Any questions on that? Let's take a look at some of my examples then. In example 1, the first thing I notice is that I have these legs congruent. I cannot do much with a trapezoid unless I know that those legs are congruent, so most of the time we're going to be working with isosceles trapezoids. With those legs congruent, then I can say a bunch of stuff. Let's start with like the easy ones. If I have these bases, I can tell that they're the bases because they have that parallel tick mark. But my base angles are going to be congruent. So if one of those angles is 117, the measure of angle 1 should also be 117. Same thing over here. If this is my base, my two base angles are going to be congruent. However, I don't know what either one of those is. How are we going to figure out what one of those angles is? Let's say angle 2. How am I going to figure out what angle 2 is? Any ideas? Gabby? The consecutive sides equal 180. So if 1 is 117, I'm going to subtract 117 to get 63 degrees for angle 2. And then from there, to get that congruent base angle, 2x minus 7 equals 63. X equals 35. Good. Any questions on that one? Okay, number 2, same deal here. I again have an isosceles trapezoid. It's important that we know it's isosceles before we try to use any of these properties. I have QS and RP. What do I know about those diagonals? Gabby? They're congruent, so let's set them equal. What is this? X equals 1. I can plug it in. 1 plus 5 is 6. RP, 3 plus 3 is also 6. Beautiful. Questions? Sticking with the theme of trapezoids, we're going to talk about a theorem that we get in conjunction with trapezoids, and that's called the trapezoid midsegment theorem. Let's back up to last unit. Do we remember the triangle midsegment theorem? How about I draw this in here to maybe refresh our memory? Does anybody remember this? I got a bunch of properties. If my midsegment and my base, they're parallel, what else do we know about them, Dahlia?
Isn't the smaller one like half the size of the larger one?
Yeah, so let's call this the midsegment, M, is 1/2 the base. So if this is M, then this is B. So my triangle midsegment theorem says the midsegment is 1/2 of the base. When I talk about a triangle, I only have one base. When I talk about a trapezoid, I have two bases. My formula is essentially the same, except I have to account for these two bases. So instead of 1/2 the base, my formula is, and you're going to have to write this down because I know it got cut off on your page, my midsegment is equal to 1/2 of base 1 plus base 2. So instead of just having one base, I can do half of it. I have to add together both of the bases. I don't like doing 1/2 times anything. So if it makes more sense to you to not have to multiply things by 1/2, then you can do 2 times the midsegment equals base 1 plus base 2. That way we don't have to divide anything by 2. Good? Any questions there? All right. Let's take a look at our 2 examples on the next page then. This one, pretty straightforward, right? I have my midsegment, 45, and I have my two bases, X and 35. I don't want to divide x by 2. I don't want to divide 35 by 2. So instead, I'm going to multiply 45 by 2, and it has to equal my two bases added together. So x equals 55 here. That's the trapezoid midsegment theorem. That's all that says. Let's do it again in number 4. This one's a little bit more tricky because we have x's, but the formula is the same. I want 2 times the midsegment, so 2 times 15 equals the two bases added together. 6x minus 3 plus 8x plus 5. I simplify. 30 equals 14x plus 2. 28 equals 14x. Oops. Or x equals 2. Any questions about trapezoids, isosceles trapezoids, trapezoid midsegment theorem? Okay. The last shape that we're doing then is kites. Take a look at kites. By definition, again, remember a kite is not a parallelogram, so I don't know that I have 2 pairs of sides parallel, but I do know, by definition of a kite, that the 2 consecutive pair of sides are congruent. And that's my definition. We're not going to try to trick you here. It is going to be obvious which 2 pairs of sides are congruent. We have in this diagram the 2 shorter sides and the 2 longer sides. So they are consecutive because they're next to each other. They're not across the shape. They're not opposites. Then we get some definitions. We get some extra properties. The diagonals of my kite are perpendicular. Where else have we seen that property? We've seen it once before. Do we remember, Caitlin? Yeah, that's from a rhombus. A rhombus also has diagonals or perpendicular. What we are going to get because we have those diagonals perpendicular is a lot of right triangle stuff. We are also going to get a lot of the time our kite properties come from things like HL, SAS, all that good stuff. Because we know we have that right triangle, we use it a lot. It shares sides. We're going to have a lot of reflexive property. I'm not asking you to prove things. I'm just asking you to pay attention to those things to figure out when are your triangles congruent to each other. We'll figure it out. The last property that we have is that one pair of opposite angles is congruent. So if I take a look at this shape, I just want you to give me your best guess. What pair of opposite angles do you think is congruent in this shape? Which 2 look like they're the same? It's going to be those 2 on the sides, right? This one looks like it's congruent to that one. You would be correct. Again, I'm not trying to trick you. What we're looking at here, and what I'm going to simplify this property down to, because from it we get a lot of extra properties, is that the long diagonal creates symmetry. Oops, if I can spell symmetry. So let's draw in that long diagonal. Actually, I'm going to draw in both of my diagonals. The long diagonal is this one right here. And what you're going to see is that on both sides, I have congruence. So my 2 angles, here and here, are congruent. The shorter diagonal is also congruent on both sides. I can see the 2 halves of my kite are congruent. I also get the same thing with angles. Obviously, I know that all of these are right angles, so all of those are 90. But I get congruent angles here and here, and I get congruent angles here and here. This long diagonal is an important diagonal for kites. That symmetry, we're going to use it all the time. And we get that why. Does anybody know why this property of having, here's my kite, definition of a kite, says these two legs are congruent, and then I get that extra property that these two angles are congruent. So what tells me, if I draw a line through the middle, what tells me those two halves of my triangle are congruent? What, like, basic property? Anybody know? This is side angle side. So side angle side gives us pretty much everything in these kites. From that line of symmetry in the middle, those two triangles are congruent by side angle side. Everything we get is side angle side here. Okay, beautiful. So those are our kite properties. There's a lot of things that are congruent in a kite. Let's take a look at example 1. What's the measure of angle 1? Caitlin. Perfect. Not only is that 90 degrees, we know these angles are all also 90 degrees. What about angle 2? Yeah, Anna? 46. Exactly, 46. Here's my long diagonal. On either side of this long diagonal, I have symmetry. So if that angle up here is 46, this angle is also 46. And what about angle 3? How do we get that? Yeah, Aubrey? 44. How did you get it? Beautiful. Questions there? What about number 2? Oh no, I'm giving you away the answers. Can we do the x's first? What's our equation for the x's? Here and here. What's the relationship between this angle and this angle? Dahlia. They're equal. 3x plus 5 equals 4x minus 30. Those two opposites are congruent. We can tell. Here's my long diagonal once again. So this is 35 equals x. How are we going to figure out y? Any ideas? We want to take the angles that we have. Maybe we want to fill some stuff in. We just found x, so I can pretty quickly figure out what x is. 3, or what these angles are. 3 times 35 plus 5. These angles are each 110. Does that help anybody? Then I start looking at my symmetry. I know that these two triangles, the one on the top and the one on the bottom, are symmetrical by this line right here. So if y is there, that's also y. If 2y minus 20 is there, 2y minus 20 is also here. Does that help? What can we set up here? Caitlin. Beautiful. We get a triangle. We're going to use our triangle properties that say 180 equals y plus 2y minus 20 plus 110. We get 180 plus 3y, equals 3y. Hello? Plus 90, or 90 equals 3y, or y equals 30. Amazing. Any questions on that? One more and then we're done. Ooh, I like this one. Okay, what do we see here? I see SW and TZ is what I'm looking for. Can we start with SW? Here's SW. What do we think, Aubrey? Yeah, here's my line of symmetry, right down the middle, the long diagonal. So if SZ is 8, then ZW must also be 8. 8 plus 8 is 16. And then what about TZ? Here's TZ. It's TZ. Don't make this harder than it has to be. Aubrey? Yeah, TR, the entire thing is 18. This part down here is 12. 18 minus 12, 6. Beautiful. Any questions?